So I'm Rachel Andrew, and I've been working with CSS since it first appeared in browsers, which makes me quite old. But I'm still here, and I'm still enjoying it, so that's good. And CSS today is absolutely amazing. I'm still as excited about the stuff that's coming into CSS as I was when I first saw CSS for the first time. But there's one part of CSS that seemed to get itself kind of stuck in 2006. And that's layout. We're using CSS for layout that was never designed for doing full-page layout of complex applications. Techniques such as float and positioning, they weren't designed for layout as we know it now. They were designed for the layout that goes back to the sort of stuff that Jeremy was talking about yesterday. Simple academic documents with a few images that needed to be laid out. They certainly weren't for responsive web applications, and that's the sort of thing we're trying to build now. And so when you view source on the web, you're going to often see things like this. This is from Bootstrap. You see all these class names and extra redundant bits of markup. And what we're doing here is we're describing our layout in markup, which is a pretty heavy-handed way of styling our pages. It makes it harder to add new breakpoints for different devices, and it's conceptually very, very heavy. But we're doing that because layout is hard, it's fragile, and we have business goals to meet. We're actually building things that are important. And I use these tools too. But there is hope. And that hope for layout comes with a group of CSS modules that are going to redefine how we do layout on the web. And that's Flexbox, Grid Layout, and Box Alignment Level 3. And they work together as a new layout system, really the first layout system we've had for the web. But first, the bad news. Browser support for the biggest of these three specs, Grid Layout, looks like this, IE only. And that's because this specification actually originated with Internet Explorer. The first draft was implemented in IE 10, so you can say thank you to Microsoft and the IE team for the fact that we have Grid at all. And you can see all the little flags on the other browsers there, and those indicate that Grid is behind a feature flag in those browsers. So unless you're using a Firefox or WebKit Nightly or Safari Technology Preview, you're going to have to enable a flag to see Grid working. And because support's a moving target, I've got a list of where we are with browsers, how to enable Grid, links to the metabugs, and more at that URL. Flexbox, at this point, is looking a lot more healthy. I'm sure a lot of you are already using it. And hopefully this talk will show you how your Flexbox knowledge can be transferred into the rest of this new layout system and will help you understand Grid as it starts to ship into browsers. So these new layout methods, we like to talk about them in terms of the problems that they solve for us. And the reason they can solve these problems is because they have some characteristics that we don't see in our existing methods, things like float. So they properly separate our document source order and visual display. They give us true alignment control, giving us the ability to center things both horizontally and vertically. And they're responsive by default. They remove the need to calculate percentages to make columns fit at different breakpoints. And importantly, they give elements relationship in terms of the layout to each other. And that's not the case for layout methods such as float and positioning, where each item is positioned kind of alone in a layout it knows nothing about. And a lot of the problems in these existing systems happen because we can't tell one element that it needs to respond to another. If I float two blocks left and right and one is shorter than the other, I've got no way to tell the shorter block, hey, could you just be as tall as that one next to you? It just doesn't know it's there. And we've been trying to create these full-height columns for years. If you're old like me, you might remember the faux columns technique, using a vertically tiled background image to create the visual impression of a full-height column. It's why people jumped on the idea of using display table. I wrote half a book on it. By turning elements into a CSS table, we gave them an understanding of how they sat in a wider layout context. And Flexbox and Grid take this idea and really run with it, and that's where a lot of their power comes from. So those full-height columns, that's pretty much the basic behavior of Flexbox and Grid. So this is a simple Flexbox example, taking advantage of the initial default values of the Flex properties. Our sidebar and our content are inside a Flex container. So the sidebar runs to the height of the content area. The background color extends all the way to the bottom. And here's how we do that with Grid. So I've created a grid on my wrapper element and positioned my sidebar and my content using line-based positioning. In all of the examples in this presentation, this concept of elements understanding their place alongside the rest of the layout is really important. So for almost as long as I've been developing websites, certainly since CSS Layout came along, we've talked about this separation of content and markup from display. That was really the rallying cry of the CSS for Layout movement as we tried to explain to our nested table-loving friends why they should move and use CSS for Layout at all. But it was something of a failed promise, and especially once responsive design came along, it's very, very hard to get the ideal document structure as well as the ideal layout at different breakpoints without compromising one of them. So here's Flexbox. We're laying out some navigation with Flexbox, just very, very simply. The Flex direction property is set to row. Again, this is the initial value of Flexbox if you don't specify anything. And you could also use column, which would display the items in a column. We can switch the visual order of Flex items by setting the Flex direction property to row reverse or column reverse. We can also explicitly set the order using the order property. So I've got a bunch of items here, and they're inside a Flex container. They're in source order, so I've given them a number so we can see their natural order. And I can just change the order with the order property. So the source order number 1 is now 3 visually. CSS Grid gives us the power to change where things are in not 1, but in 2 dimensions. So here I've got a parent element set to display grid, and I'm creating a grid with 3 columns. And positioning items around that grid, again, using the grid column and grid row properties. And so we can do this, and we can leave white space, and that's fine. The constraint here is that grid items, like flex items, need to be a direct child of the element that's become a grid container, but then we can position things in 2 dimensions around a grid. In addition to this placing of items, deciding where we want things to sit on our grid, Grid Layout also includes a set of auto-placement rules, and they allow us to take a chunk of content, hand it to a grid that we've created, and Grid will just lay it out for us. So if I removed all the positioning information from the previous example, I'd get this. These are my child items just laying themselves out, 1 in each grid cell. If I add some more images to that gallery, and some of those images are landscape, and what I'd like is landscape images to display across 2 tracks of the grid. So I'm adding a class to my LI elements that contain a landscape image. I'm then setting the grid column end property to span 2 lines. So that's going to have this effect of making landscape images span 2 tracks, while portrait ones stay with the default 1 track. And we get this. So the grid auto-placement algorithm comes along, it lays out our items, and sometimes, so between our images here, 2 and 3, the items won't fit on 1 line, so Grid just leaves a gap and carries on the next line. It keeps the elements in source order. But if we add a property of Grid auto flow with a value of dense, Grid will now backfill the gaps. It moves through the content, it finds an image that will fill a gap already left, and so it picks that up and it places it into the space, taking it out of DOM order. You can see that item 4 now becomes before item 3 in the visual display, which is absolutely fantastic for your image gallery, not so great for your form. So there is a huge implication here in terms of accessibility. What happens if the visual display ends up totally out of sync with the source order? What happens for people tabbing around the document, for example? Ideally, these new methods should enable us to create the most accessible source documents, then use the power of reordering to display things in the most optimal way for each breakpoint, considering how someone tabbing around with the keyboard, for example, might be using the document. I think there's a real danger, however, that the reordering capability will encourage people to simply forget about source order, or even worse. Because elements only become Flex or Grid items if they are a direct child of the Flex or Grid container, will there be a temptation for authoring tools or developers themselves to start to strip semantic markup, flattening out the source to make everything a child of the grid? The editor's draft said, for Flexbox and Grid, warn against this. Order shouldn't change how a document is read out in text-to-speech or change anything about the logical order. So when we're doing this reordering with Flexbox and Grid, it should be for visual reasons, not changing the logical document structure. And I'd really encourage anyone who is looking at this new layout stuff to watch this video from Leonie Watson, because she demonstrates with a screen reader how the problems actually manifest themselves. And it's really, really worth having a look at that as you're starting to use these new techniques and just understand the potential accessibility problems. I think we've got, as a community, lots of discussions to have around this stuff. So moving away from reordering, it does appear that the hardest challenge in web design has been vertical alignment. And that is something that our new layout methods solve. And this is why I bring a new player into the picture. This is the CSS box alignment module. It contains the features of CSS that relate to alignment. And what it does is it brings all the really cool alignment things from Flexbox into a separate module so that it can be used by other CSS modules. At the moment, we're seeing that implemented in Grid Layout, but there's no reason why it couldn't become a part of other kinds of layout in the future. So this basically is the vertical centering module. Although it's more than just vertical centering, it covers things like distribution of space, overflows, and logical positioning. So we get a set of alignment properties. I could easily use half an hour just talking about alignment, but very quickly. We've already seen one value of box alignment in the very simple Flexbox example. Justify content, space between, spaces are items out evenly. We can do exactly the same on a grid container. Assuming the total width or height of the tracks is smaller than the size of the grid container, we can use space around or space between to space things out. And alignment. Here I've got 4 items in a list. We're laying those out with Flexbox. Now the first item is a portrait image, and it's at the default stretch. That's the tallest item, so it's dictating the height of our Flex container. So our second item is then centered. The third item is aligned to the start, and the fourth is aligned to the end. And we can do exactly the same with Grid Layout. So I'm creating that same layout with Grid. And then for Grid, we have align self-center, align self-start, and align self-end. In this case, we're aligning the item inside the grid area, which may be 1 or more grid cells. Being able to align items and groups of items is really important for responsive design. It makes it an awful lot easier to do that sort of stuff. And that's the great thing about these new methods. These methods have come about in a world where responsive design is already a thing, and so they understand that that's the kind of layouts they're going to be part of. It was actually 2009 when Ethan Marcotte wrote his A List Apart article and discussed his technique for creating fluid grids. And this is the technique that left us all adding these unlikely looking percentage values to our designs. And one of the reasons why many of us fall back on using frameworks or preprocessors to generate our grids, because we don't want to be sat there with a calculator writing out strange percentages. But these new layout methods, they mean it really is time to retire a lot of those calculations because they do this stuff for us. CSS works it all out for us. The space between and space around values we've seen are a very simple example of this. They grow and shrink according to the available space in the container. Flexbox goes further than this, however. It allows us to distribute space in proportion between our items. The flex property is a shorthand for 3 properties: flex grow, flex shrink, and flex basis. So here I'm setting flex grow and flex shrink to 1, which means that every box can grow and shrink to fit into the space, but the ideal box width is 300 pixels. which would give us 3 boxes of equal width because they can all grow and shrink the same amount. If we allow the items to wrap and we add some extra items, we can drag the window smaller. And when the box gets smaller than 300 pixels, a box will wrap onto line 2 to try and maintain that kind of width. And as the boxes can grow from their flex basis, the boxes on row 2, where I've only got 2 boxes, split the space between them. They don't line up with the items above. Each row is treated as a flex container of its own. We can target individual items. So I've added some rules here for box 3. All the boxes can grow and shrink from 300 pixels, but box 3 can't grow. So the boxes are stretching wider, but it stays at 300 pixels. So that's useful if you want to have some fixed elements inside your design. You don't want them to grow and other things to take up the available space. But there's more because we can use proportions as well. So if we assign different values to the flex grow and flex shrink properties, we can say how much we want the things to grow. So I'd like box 3 to flex grow 2. The other 2 boxes remain at the default of 1. In this case, it doesn't mean that box 3 becomes twice the size of the other boxes. It means that after the 300 pixel basis has been taken away from the available width in the container, the rest of the space is assigned to each item according to the flex grow value. And note, this has no effect on the row below. That's a different flex container. As a tip, if you want to work out how different flex factors will add up, here is a handy calculator. You can stick in different values. It'll tell you what you'll actually end up with. It's quite useful for just getting your head around how it works. So Flexbox lets you assign space line by line, so row by row or column by column if you're working in columns. Grid takes the other approach. We define a grid and then we fit items into it. And to do this, Grid introduces a new unit, the FR unit. It's a fraction unit. And if you understand how FlexGrow works, you've got a head start in understanding the unit. Because like FlexGrow, it allows you to assign a fraction of the available space in a grid container. So let's take a quick look at that. This is a very simple grid. It's defining 3 columns, all with 1 fraction unit as the width. So that creates 3 equal width columns. We don't need to add anything to the items. We just create a grid, and they get placed in it by the auto placement rules. If I change my definition and create 1 600 pixel column and 2 1 fraction unit columns, Grid gives that fixed width element. It's 600 pixels. The remaining space, it divides up between the 2 1 fraction unit columns. If we change that last column to 3 fraction units, the remaining space is divided into 4 and shared between the boxes in proportion. Unlike Flexbox, however, we're setting the size of the complete column track. If I add another row, the proportions stay the same. And this is the key difference between Grid and Flexbox for layout. At a very basic level, the 2 specs differ. Flexbox is designed for one-dimensional layout. That's laying things out in a row or as a column. Grid has been designed for 2-dimensional layout. That's rows and columns at the same time. So something nice about Flexbox is the ability to get as many items as will fit in a row. So as the window here gets smaller, Flexbox fits in as many items as possible using 300 pixels as the basis. Additional space distributed against each row equally. And we can do this with Grid. In this case, though, we're creating flexible tracks and then placing the content into them. So here, I'm autofilling as many columns of 300 pixels as will fit into my container. As the maximum value is 1 fraction unit, that means that any available space left over after I've done as many 300 pixels as I can gets distributed amongst the columns equally, which gives us this. So as you can see, unlike Flexbox, items that go into the next row stay lined up in their column. That's 2-dimensional. So in practice, we're going to be using Grid and Flexbox together, choosing the right layout method for each task we want to achieve. So as a final demo, I wanted to recreate a pattern I've seen on a number of websites, a hero block with lots of different panels, and sometimes they're used for navigation. And I spotted this one on a tutorial site. Now, the problem with these things, as you'll see, is that to get this neat lining up of items, what tends to happen is people fix the height of their blocks. So if additional content gets added, or the content's bigger, or something happens, then what we end up with is overflows, or content getting cut off, which isn't great. Now, with Grid Layout and Flexbox, we can create this kind of thing in a much more flexible manner. So this is the thing I created. I'm redefining the grid at 2 breakpoints after my initial mobile width, essentially matching the example that I was playing with. And so I'm moving to a 2 or 3 column layout. So the heights of the rows appear fixed at 150 pixels, which is just like the design I was copying. But as soon as I add extra content, as you can see in the sort of top right box there, the row expands to contain the content. And because that box needs to expand, it expands right across the row. So the 2 items to the left of it also get taller in order to take up that space. So we've got more paragraphs in one, and that's pushing out all of them, but the thing all still lines up at the bottom nicely. And this works by using the min-max function in my track sizing. So min-max is something else that you'll see in the grid layout spec. The grid auto rows property gives a height to the rows that grid creates as content is added. I'm using min-max here to get a track that is at least 150 pixels tall, which then works according to my design. That's my ideal look for this design. But if more content gets into the box than I expected, the layout doesn't have things overlapping. It copes, it just grows to auto. So it grows bigger than 150 pixels. So this means we can create these very precise layouts, but that if they hit the real world of a content management system and someone who decides to add a lot more content than we ever thought, they'll still work. They'll cope with the extra content. And I'm using Flexbox as well. Inside the cells, I want to push the content to the bottom of some of my cells, and so I'm using Flexbox there to get that kind of behavior. I mentioned a CMS. A lot of content these days comes out of a CMS. We don't carefully create all of our content to fit the items. And in the real world, not all CMSs are great at preventing people adding more content than is expected. So in this case, perhaps someone's come along and they've added another box. They've added one more box of content to the design. And Grid Layout just copes with that. It just adds a new box. OK, that box isn't as pretty as the others, and it means that we've got a box at the bottom that we didn't expect, but we're not getting overlapping content. It's not broken. People can come to the website and read the stuff. This is where we're heading. We're heading to a future where we can create far more responsive designs and designs that accept a whole lot of different content being put into them, being able to create rules around that, rather than having to kind of really fix things in order to get really good design. And you're going to see some fantastic examples later in Jen Simmons' talk where she shows some of the creative things that you can start doing with these new specifications. So please do start having a look at what is coming with Grid Layout and the sort of things that you're going to be able to do with it. All the demos I've shown you today are in this CodePen collection, so you can go and fork those and have a play around with them. And for Grid specifically, I've got a lot of examples over at gridbyexample.com and also some resources. And I know this can't be used in production today, but Grid is going to land cross-browser pretty soon. And this is why we should be looking at this stuff now. Once a specification like Grid is out there and live, making changes to it is almost impossible because it will break production websites. Grid is being developed behind browser flags in order that changes can be made before it gets out there onto the web. And this is going to be the way of things in the future. Vendor prefixes are essentially going away because what happened with prefixes is people used code that wasn't intended for production, they used it on real websites, and then got upset when stuff broke because things changed in browsers, they changed in the spec. Most of the cross-browser issues in Flexbox aren't because some terrible browser just did their own thing and implemented something that wasn't in the spec. The spec actually changed underneath the browser implementations. And so we ended up with different things in browsers. Developing behind flags means that issues can be worked out before they get into the wild, because once they're out there, it's hard to go back. This is the list of things that the CSS Working Group are going to change once time travel is invented. So we can't take this stuff back, and I think you'll be hearing some about this later on as well. So please do look at things that are behind flags, enable flags in the browser, look at the new stuff that's coming into CSS and the technologies that you use. For CSS, it's getting a lot easier because now the spec issues are all on GitHub, so raising an issue or commenting on an issue in the spec is as simple as going to GitHub and doing that, just the same as with any other project. Please do that. Think of it as a good deed for your future developing self. Look at emerging specifications while you've got the chance to, because otherwise you're essentially leaving your future as a designer or developer in the hands of the very few people who do. Thank you very much for listening, and do ask me some questions later. I'll be around all day.